Hey, this is Mr. James. In this video, we're going to be talking about special right triangles. Now, there are two types of triangles that occur often in geometry and trigonometry. They're named special right triangles, and they're the 45-45-90 triangle and the 30-60-90 triangle. And they're found in the following figures. If we take a square, right, let's say we take a square, and we cut it in half across this diagonal, what kind of triangle do we make? Well, we know that the vertices of a square are all right angles, 90 degrees, so let's fill those in. And if we draw this diagonal in here, we're basically bisecting or cutting this angle in half. So half of 90 is 45, and so we create some 45-degree angles there, and 45-degree angles there, okay? And so what's left are these two triangles here, and each one of them we call a 45-45-90 degree triangle. And this triangle is important to us because it comes up in a lot of areas, such as finding perimeter, area of squares, and various other shapes. The other kind of triangle that comes up often is the 30-60-90 triangle, and it's part of an equilateral triangle. Remember, in an equilateral triangle, all of the angles are 60 degrees. So here's a 60-degree angle here, here's a 60-degree angle here. And suppose we drew this altitude, or this height in this triangle, such that it formed a 90-degree angle here, so a 90-degree angle, and also it bisected or cut this top angle in half. So instead of being 60, half 60 will be 30, so 30 degrees each. What's left is what we call two 30-60-90 triangles. 30-60-90 because they have 30, 60, and 90-degree angles. And this kind of triangle, just like the 45-45-90 triangle, will come up a lot in geometry and trigonometry for finding things like area, perimeter, volume, all sorts of stuff of equilateral triangles, other kinds of triangles, and various bigger polygons. Now, if these two triangles, the 45-45-90 and the 30-60-90, come up so often in geometry, it might be nice to know something about the sides of those triangles. So let's take a look at this one first, this 45-45-90. Suppose that this square had this side length as 1. That's 1 right there, 1 centimeter maybe. Well, since it's a square, we also know that every other side, including maybe this bottom side right here, would have a side length of 1. Remember, because all the sides of a square are congruent. Can we figure out what the length of this diagonal, this other side of the 45-45-90 triangle is? Well, we could with a little bit of help from Pythagorean theorem. So we would have, let's see, 1 squared plus 1 squared equals, we'll call this length c. And after finishing Pythagorean theorem, we find out that this diagonal actually has a length of the square root of 2. So our basic 45-45-90 triangle has side lengths 1, 1, and the square root of 2 across from the right angle. What about an equilateral triangle? Can we learn something about the side lengths of that? Let's call this length down here 1. Let's say that's 1 centimeter. Well, since this altitude, this segment, cut the bottom of the triangle in half, this is also 1 over here. And so this whole length on the bottom is 2. Well, since this is an equilateral triangle, if this bottom part is 2, then this side has also a length of 2. Okay, so we've got 1, 2 for this side. What about this segment in the middle? How long is that? We could do a little bit of Pythagorean theorem using 1 and 2, since this is a 90-degree angle. Let's see, we would have 1 squared plus b squared, that's this height right here, equals the longest side, the hypotenuse, 2 squared. In theorem, we find that this has a length of the square root of 3. So a 45-45-90 triangle has lengths 1, 1, and square root 2, whereas an equilateral triangle has lengths 1, 2, and the square root of 3. Before we keep going in the notes, let's actually see how we might use these two kinds of triangles. Let's start by looking at the 45-45-90 triangles. Remember, the most basic 45-45-90 triangle has side lengths 1, 1, and square root of 2. Remember, across from the 90-degree angle. All of the other triangles in this slide right here are also 45-45-90 triangles. So we have 45, 45, and 90 here. For this triangle, we have 45, 90, and blank. But if you remember that the angles of a triangle sum up to 180 degrees, you can subtract and find this is also 45 degrees. And over here, it looks like we've got this isosceles right triangle. But if you remember that the angles of a triangle add up to 180 degrees, you subtract out 90, and then divide that by 2 for these two base angles, you'll find out these are both also 45 degrees. So all 45, 45, 90 triangles. And since they are all 45, 45, 90 triangles, by angle-angle similarity, since these all have the same angles, these triangles are all similar. And since the triangles are similar, these sides are proportional to each other. And so let's say we have this basic 45, 45, 90 triangle, and we want to fill in the other sides of this triangle. There's two ways we could do it. The longer way would be to write a full-out proportionality ratio. So we could just say something like 1 to 5, 1 to 5, and let's say we want to find what this side is right here, x. We would say 1 to 5, and the square root of 2 to x. Square root of 2 to x. We would cross multiply. 1 times x is x. 5 times the square root of 2 is 5 square root 2. And so x is 5 square root 2. That's the long way. But if you look at this, you don't actually have to do that. Think about this. We're going from 1 to 5. What do you have to multiply or divide by to get from 1 to 5? You have to multiply by 5. That means that since these triangles are similar, every other side will follow that same ratio. So square root of 2 times 5 is 5 square root 2. 1 times 5 is 5. Easy. Let's take a look at this triangle down here. This square root of 2 corresponds to this 3 square root of 2. So how do we get from the square root of 2 to 3 square root of 2? Well, it looks like we're multiplying by 3. And so following that ratio, 1 times 3 is 3. 1 times 3 is 3. So the side lengths of this triangle will be 3, 3, 3 square root 2. And that follows this pattern of 1, 1, 1 square root 2, or just square root of 2. Taking a look at this last one, let's see, the square root of 2 corresponds to 7. So how do I get from the square root of 2 to 7 by multiplying or dividing? What kind of ratio will that be? I actually don't know off the top of my head. Square root of 2 to 7? I have no idea. So we're going to have to do this one the long way. Let's write a similarity ratio. The square root of 2 to 7. Now let's call this side x and say 1 to x. All right, square root of 2 times x, square root of 2 times x, and 7 times 1, 7. To get x by itself, I'll have to divide by the square root of 2. And so that means that x equals 7 over the square root of 2. That's a little bit funny, but that's how we're going to leave it. This side is 7 divided by the square root of 2. And since these two sides are equal, this is kind of an isosceles right triangle, this is also 7 over square root of 2. Now later on in this video, we're going to talk about why this kind of answer might not be the best answer for us, but for now we're going to leave it as 7 over square root of 2. Now that we've talked about 45, 45, 90 triangles and how they work, let's take a look at these 30, 60, 90 triangles. From our notes, we've learned that the most basic 30, 60, 90 triangle has sides 1 across from the 30-degree angle, 2 across from the 90-degree angle, and the square root of 3 across from the 60-degree angle. And looking around, all of the triangles on this slide are all 30, 60, 90 triangles. 30, 60, 90, 30, 90, and if we remember that the angles sum to 180, we could subtract and find this is 60. And similarly, this is going to be 30 by subtracting from 180. Just like with the 45, 45, 90 triangles, since these all have the same angles, by angle-angle similarity, all the sides will be proportional. So let's take a look at this. From 1 to 5, because this 5 corresponds to this side, they're both across the 30-degree angle, what's going on from 1 to 5? Well, from 1 to 5, we are multiplying by 5. So all the other sides will follow that same proportion. So 2 times 5 is 10. Square root 3 times 5 is 5 square root 3. So 5, 10, 5 square root 3. That follows the same pattern over here. Let's take a look at this triangle. First, what does this 8 correspond to? Well, this 8 is across from that 90-degree angle, which means it's going to correspond to this 2 side. So how do you get from 2 to 8? Well, you multiply by 4. And so if that's 8, let's see, the bottom side corresponds to 1, so 1 times 4 is 4. And square root of 3 times 4 is 4 square root 3. So you have sides 4, 8, and 4 square root 3. Just like we had here, just like we had here. Let's look at this last one. This 7 corresponds to the square root of 3 side. Now how do you get from the square root of 3 to a 7? I'm really not sure, right? I'm not sure what you have to multiply by to do that. So we'll have to set up a full proportionality ratio to figure this out. So square root of 3 to 7. So square root of 3 to 7. Let's go for this side first. Let's say 1 to x equals 1 to x. So we have 1 times 7 is 7. Square root of 3 times x. Doing a little cross multiplying there. And then to get x by itself, we divide by the square root of 3. So x equals 7 over the square root of 3. Now that's kind of odd, but for now it's how we're going to have to leave it. 7 over the square root of 3. And this side, remember this length right here, is double this length. Remember 5 to 10, 4 to 8. And so if this is 7 over the square root of 3, this side will have to be 14 over the square root of 3. Like I said in the last video, we're going to learn in just a few minutes why this is probably not the best way to leave our answer. But for now, that's how we're going to leave it. At this point, let's try some practice problems. Pause the video now and try these 3 right here. 1, 2, 3. Pause the video now. The answers are coming up in 3, 2, 1. Let's take a look. This first triangle is a 45, 45, 90 triangle. We know because we've got a 45-degree angle here, a 90-degree angle, and we could subtract from 180 to figure out that that angle is also 45 degrees. In any case, it's going to be similar to this 45, 45, 90 triangle. It's got sides 1, 1, and square root of 2. So what does this 3 correspond to? Well, this side right here, this 3, corresponds to the side of 1. And so it looks like we're multiplying by 3 to get this triangle. 1 times 3 is 3. 1 times 3 is 3. And so the square root of 2 times 3 will be 3 square root of 2. So we're following the same pattern as this basic 45, 45, 90-degree triangle in this new one down here to get the 3 square root of 2. What about this next one? Let's see. There are no angle markings in these two angles, but we can figure out this is a 45, 45, 90-degree triangle because, look at this. These two sides are both labeled x, which means this is going to be an isosceles right triangle. All isosceles right triangles have angles 45, 45, and 90. Well, let's move on from there. What side does this 5 correspond to? Well, this 5 seems to correspond to the square root of 2 side. And how do we get from the square root of 2 to 5 by multiplying or dividing? I don't really know. So I'm going to write out a full similarity ratio, or full similarity proportion for this. So 5 to the square root of 2, and let's go from x to 1, and let's see, 5 times 1 is 5, x times square root of 2 is x square root of 2. We will divide both sides by the square root of 2 to get that x by itself, and we're left with x equals 5 divided by the square root of 2. That's kind of funny, that answer. And actually, we're not going to leave that answer like that for long, but for now, we'll just leave it that way. We haven't learned anything else to do yet, so our answer is 5 divided by the square root of 2. This last one, clearly a 30, 60, 90 triangle, so we're going to use this triangle right here as our reference. So, what does this 5 side correspond to? Well, this 5 side corresponds to the square root of 3. Now, how do you get from the square root of 3 to 5? I don't really know. So, I'm going to set up a similarity ratio. We can go from the square root of 3 to 5. Notice that those sides correspond because they're both across from the 60-degree angle. And the 5 is across from the 60-degree angle right here as well. So square root of 3 goes to 5. And let's go for s first. What does that correspond to? 1. 1 corresponds to s, so 1 over s. 5 times 1 is 5. Square root of 3 times s is s square root of 3. We divide by the square root of 3 to get s by itself. And so we have, s equals 5 divided by the square root of 3. Nothing we can do to simplify that right now, so I guess s is just 5 over the square root of 3. And we learned in previous videos that, remember this side right here, this 2 side is double the length of this 1 side. So if s is 5 square root of 3, then t will have to be 10 divided by the square root of 3. Again, it's a little bit of a weird answer because we're dividing by a radical. And in the next video, we're going to learn what to do with that divided by radical and a way to make this answer look a little bit different. That's the end of the first video. Please make sure you watch the next one to finish out the notes.